55 million light-years from Earth, the supergiant elliptical galaxy Messier 87 hosts a stream of plasma erupting from its dense core. To understand what powers that stream, we look at this data. Captured in 2019 by the Event Horizon Telescope, this image shows the source, a dark central shadow bounded by an asymmetrical glowing ring. This is a mathematically synthesized map of electromagnetic radiation, captured at a highly specific 1.3 millimeter wavelength. Resolving an object of this size at a distance of 55 million light-years requires very long baseline interferometry, a technique that synchronizes independent radio antennas spread across the globe. To cut through the interference of Earth's atmospheric water vapor, these millimeter wavelength observations rely on specific high-altitude arrays, like ALMA in the Atacama Desert. But capturing a clear signal is only half the problem. Achieving the angular resolution necessary to see the event horizon requires extreme geographical baselines, pushing the network all the way to the South Pole Telescope. By linking these distant dishes with atomic clocks and supercomputers, the collaboration effectively created a virtual phased array with an aperture the diameter of our entire planet. We can now reverse engineer the physical engine operating at M87's core by deconstructing the specific pixels in this data map. The global network has taken the black hole out of the realm of theoretical metrics and placed it onto the observable spectrum as a thermodynamic engine bound by strict, measurable parameters. This maps the shadow against the true event horizon, which is roughly 2.5 times smaller. By the no-hair theorem, the black hole sheds all physical properties of infalling matter. Its geometry is determined exclusively by its mass, 6.5 billion solar masses, and its angular momentum. The data surrounding that shadow reveals the behavior of superheated matter trapped in its gravitational well. Due to a physical effect called relativistic beaming, plasma moving toward an observer at near light speeds appears significantly brighter than plasma moving away. Because the southern, bottom section of the ring is measurably brighter, we know that part of the accretion flow is approaching Earth. The black hole anchoring this entire system spins clockwise. Surrounded by the chaotic mechanics of a galactic core, the singularity itself remains a perfectly smooth mathematical boundary defined solely by its mass and its spin. To maintain that dense, glowing ring, the black hole requires a continuous supply of thermal mass. This supply often begins when a star strays from a stable orbit and approaches the supermassive black hole on a highly elliptical parabolic trajectory. Entering the gravitational well, the star crosses a threshold where the black hole's tidal force outpaces its internal self-gravity. This equation defines the tidal disruption radius, mapping the exact distance where a solid stellar body fails under gravitational stress. Crossing that boundary triggers a tidal disruption event. The star is violently stretched and spaghettified into a continuous, high-velocity stream of plasma. The shredded stellar material loops tightly around the black hole, colliding with its own tail to form a superheated accretion disk. However, the math dictates a strict limit. If a central black hole exceeds roughly 100 million solar masses, its tidal disruption radius falls completely inside its Schwarzschild radius. Above that mass threshold, an incoming star crosses the event horizon intact. It is swallowed whole without generating a visible accretion flash. For observable tidal disruption events, telescopes detect a rapid spike in optical brightness, followed by a specific decay curve as the matter is consumed over months or years. The radiant ring captured by the EHT represents the active, luminous exhaust of this accretion process, an environment fueled in part by these shredded stellar remains. This polarized image, released by the EHT collaboration in 2021, traces the sweeping, spiraling magnetic field lines embedded within that accretion flow. These fields interact directly with the black hole's angular momentum through frame dragging. As the massive singularity rotates, it drags the physical fabric of spacetime along with it. This cross-section models a spinning, or Kerr, black hole. The shaded area immediately outside the event horizon is the ergosphere, a region where the frame-dragging velocity exceeds the speed of light. Inside the ergosphere, the metric of spacetime changes sign. Resisting the rotation becomes mathematically impossible, and all matter is physically forced to co-rotate with the singularity. Because objects are forced to move, the black hole contains accessible kinetic energy. physicist Roger Penrose formulated the thermodynamic mechanism required to tap into that kinetic energy. In the Penrose process, a working body falls into the ergosphere and splits. One fragment falls past the event horizon. The surviving fragment is violently ejected, leaving the black hole with up to 20.7% of its rest mass converted into extracted energy. Channeled by intense magnetic field lines, this extracted energy erupts from the void's magnetic poles as a highly focused beam. The black hole actively sacrifices its own rotational energy to spin itself down, generating the power required to drive its massive plasma jet. The mechanics at M87 star demonstrate a complete thermodynamic cycle, from the acquisition of fuel to the violent exhaust of energy. The shredded stellar mass feeds into the glowing accretion disk, continuously funneling thermal plasma into a central void. At the very center, the no-hair theorem enforces a perfectly smooth geometric boundary defined only by 6.5 billion solar masses and a clockwise spin. That spin creates the ergosphere, acting as a cosmic turbine that forces all surrounding matter and magnetic fields to co-rotate. Through the Penrose process, the magnetic fields extract this raw rotational energy and fire it outward as a relativistic jet. When we map the millimeter wave data from the EHT onto wide-field radio and X-ray observations, the localized photon ring perfectly aligns with the macroscopic jet structure. A local boundary, roughly 40 billion kilometers wide, dictates the energy distribution and evolution of an entire supergiant galaxy. The specific pixels captured by the Very Long Baseline Array represent a direct measurement of the thermal and magnetic exhaust generated by this cycle. The data from M87 confirms that black holes operate as the ultimate energy conversion devices in standard physics, dynamically driving the evolution of the universe around them.